Hello, quarantine kids. We are going to be talking about DNA some more in forensics class. So this is a picture here of the process of DNA fingerprinting, which is something I'm going to explain to you. What we're going to be doing on Friday, December 11th, we are going to be going over some notes, and then we're going to be doing a QR code question activity. So I will explain all of that momentarily. First, let me pull up the notes. So let me pull those up. Here we go. So we can talk about those. So first, what you're going to be doing first is, we're going to learn how DNA can be collected from a crime scene, how can it be taken from a suspect, and then how can you link it back to the particular suspect. So to be able to do that, you'll need some background information. So I want you to watch this short video. I think it's like 8 minutes long from the Amoeba Sisters, and they do a pretty good job explaining the basics about DNA. Then we're going to talk about DNA in forensics. So this is about where we got to on Thursday, about this spot. And let me just go ahead and push present, and we'll just go ahead and we'll talk about it here. Here we go, from current slide. So we know that everyone has their own unique DNA, except for identical twins. And even though identical twins do have some differences, and those are caused by maybe changes in the environment in the womb or what's happened environmentally to each person after they've been born, their DNA is still exactly the same. So that can be a muddle for crime fighters if one twin commits a crime and frames the other one. That's something to think about. So we have been getting better and better at using DNA technology to solve crimes, because DNA is actually individual evidence, not class evidence. It's individual evidence, direct evidence, because it can be linked to a specific individual person. Okay, so here is how we can collect DNA. Any of the following cells, any kind of cell from your body, any cell will have the entire strand of DNA. It will have all the instructions for your entire body, but not every cell has the same function. So just because it has all the DNA there doesn't mean it's going to do all the functions of every cell in your body. So if you have a skin cell, it's going to behave like a skin cell. It's not going to function like another type of cell, like a blood cell, but it still has the entire strand of DNA. So it actually has instructions on how to make your blood in the nucleus of a skin cell. We can replicate DNA. We can actually theoretically get DNA from a single cell. We know how to replicate it. So because we can take DNA and we can replicate it, we can make as much DNA as we want to be able to test. So that is something that has been an advance in DNA technology. When they first started using DNA, they had to make sure they had enough of a sample at the crime scene to be able to pinpoint a specific individual. But now, gosh, we can get it from a single cell. You can get enough if you can replicate it. It doesn't always work, but it can be done. So you can get it from skin, blood, saliva, urine, semen, hair. You could get it from any type of cell in the body. An eye cell, you could get it, eyeball cell. So DNA fingerprinting, also known as DNA profiling, is used for criminal cases, but also it's used to determine who the baby daddy is. They can use DNA and they can match it to both parents, so they can tell if someone's actually related to someone else. This is actually kind of interesting from a DNA standpoint too. What scientists are beginning to do now is they're beginning to take the databases from things like 23andMe or Ancestry.com, where you send off your DNA to those places, and then they will tell you who you're related to, and they will tell you like what percent of your DNA comes from what background. But they will keep your DNA on file. Now, some of those places, you sign a waiver when you send your DNA in that they can use it however they want. So crime fighters have started looking at the DNA in those databases, and they're finding the relatives of criminals, and they don't have the DNA from the criminal on file, so they weren't able to make a match. But now that they have the relatives' DNA, they can go back and go to that relative and say, hey, we think that someone in your family is guilty of this crime, and then they can create suspects from that list, find the suspect's DNA and it'll match. That is how they got the Golden State Killer, who was a rapist and killer in California. And I think he raped and killed over 50 people. And he was a police officer. So they did not have his DNA on file, and he got away with doing all of that. And he's an older man now. I think he's like in his late 70s. But they were able to catch him because they found the DNA of his cousin or someone on one of those databases from one of those ancestry websites, and they were able to determine who he was by looking at his relatives' DNA without their permission. So that's something that's going to run through the court system. People are appealing those convictions because they're like, hey, I didn't give permission for you to use my DNA. And so who knows how that'll probably go all the way up to the Supreme Court. And the Supreme Court will have to decide whether or not that's okay. So it'll be interesting to find out. So not only are we using it in criminal legal cases, but also finding out the parentage and who the relatives are is helping with solving crimes too. So moving on, here's a picture of the structure of DNA. We know, you guys all know it's deoxyribonucleic acid. The deoxyribose is the sugar, and then it's also considered a nucleic acid because it has nitrogen-containing bases there. The G and C and A and T that you heard the Amoebo sisters talking about. So the DNA is located in the nucleus of the cell and carries all of the genetic information for that person. And here's a picture of picture of the DNA kind of stretched out, like I showed you in the last video that it was kind of it was a double helix. Let me get the model. Sorry, I left it on my desk. So here's the model. So this is a double helix where you have both the two rows are kind of twisted, and that is what this is called, a double helix discovered by Watson and Crick, who got the Nobel Prize for figuring out the structure of DNA. So each little area is called a nucleotide. So we have a phosphate, a sugar, and a base. That is a nucleotide right there. All the nucleotides on one side put together make one single strand, and then the bases that match up and make the nucleotides on the other side make the double strand. So you have to have both to be considered DNA, double-stranded DNA. Okay. There are billions of nucleotides in the human DNA, but there are only 4 types. And so you've got the 4 types here, the bases thymine, cytosine, adenine, and guanine. And as you saw, the Amoebo sisters talked about apples in the tree and car in the garage to help you remember which ones match up. So what really codes for your traits is the order of the base pairs. So there are billions of them. So the order of the base pairs, that's a code. It's like a digital code. And that is what tells your body to make you the way that you are. Okay. So we've got all of our bases that are meeting up, and all of the proportions are different for each amount that you have in there. But adenine and thymine are always the same. Cytosine and guanine are always the same. So that here's a graphic up here to show that. That's one of the things that makes you unique from someone else. So the way they pair up and the order in which they pair up, that's what gives you your traits. And that also is what makes each person's DNA individual and unique. This is a fairly new technology. I think it was back in 1984, maybe, that the first scientist was able to make a blueprint of someone's DNA and use that. I'm going to show you how they do that. And then the first conviction was maybe 1986 or 1987. And that was actually in Britain, the first conviction. So this is new technology. It took a while before juries were comfortable convicting someone with DNA, and now they kind of expect it. When you have a crime, they're like, well, where's the DNA? They've gotten so used to seeing and hearing it on TV. Each person has a little bit of the DNA, and that's called junk DNA or non-coding DNA. And it's a pattern that they didn't used to think it coded for anything, but now they're beginning to think maybe it does. So this is all brand new science. At any rate, it's a repeating pattern, and it repeats in multiple places in your DNA. That little junk DNA, that part of repeating DNA, that is what they use to identify you. That junk DNA for you is different than every other person as far as we know. Now, it's impossible to look at the DNA for every single one of us throughout time. So you can't say with 100% certainty that everyone has different DNA, but it's as close as you possibly can get to that, because we've never found any that are exactly alike. Okay. Whoops. Alrighty, so when you find DNA at a crime scene, scientists will put it in a database, and they will look for a match in the criminal database of DNA. It's called CODIS. So they look for the DNA in CODIS, and if it's not there, then it's not useful. So they have to have a sample for comparison to be able to find the suspect. So we've got unknown DNA, we put it in CODIS, we can't figure out who it is. So that's what happened in the case of the Golden State Killer, when they went and started looking at the databases collected by the Ancestry DNA companies. So if you do have a suspect, then you usually get, you collect it. Most of the time it's like a cheek swab to get your DNA, and they can subpoena. There are crimes in which DNA has actually been subpoenaed, so they can come to you with a warrant and say, you have to give us your DNA. So what you're going to do now after finishing that is you're going to do a QR activity. So let's escape from this PowerPoint, and then I'm going to show you. So I've got on this activity, it's on your agenda, I've got questions. So here are the questions. And obviously you're not going to have a partner and you're not going to be moving stations, but I am giving you the QR code. So I'm going to give you the QR code, and you, if you don't have a QR code reader, then you can Google the answers, but it's probably easier if you use the QR code. So there's 12 questions here that I want you to answer. And then the other, let's see, I'll open it for you. Here's the activity, and here are the questions. And the other link will take you to the QR codes themselves. So you can open this on your computer. You should be able to use your phone, and you can read the QR code, and then that will take you to the website for the question. If that doesn't work and you can't use the QR code, you can just Google the answers. So whatever's easier for you. But those are some review questions that go along with the discussion we just had. So once you're done with those questions, then you can complete that and upload it to the assignment for credit. I doubt we're going to finish this whole big discussion and all these questions on Friday the 11th. So I will probably continue on with this on Monday. So that if you don't get a new video on Monday, then you know we're still working on what we just talked about here. Good luck in quarantine. If you have any questions, please be sure to reach out to me. Thanks. Bye. Oh, and have a good weekend.